unless you say something, your face didn't come up. All right, so we are going to write for this problem log. What is the base? You can just hold your fingers up. The base of this is 2. So log base 2 of what? What goes next to it if we're rewriting this as a logarithm? Log base 2 of 1, good, is equal to 3r plus 2, because 3r plus 2 was in the power. Do we see how now the variable is on a level that we could actually solve for it? Before we couldn't get it out of there. Now we're good to go. And so when you get to this point, you want to evaluate what this log is. You can do this one using properties, or if you forgot your properties, you could always put it in the calculator. But if we're thinking about it, any log of 1 with any base is always going to be, anybody remember what that is? 2 to what power gives us 1? 2 to the 0 power gives us 1. So log 1, doesn't matter what the base is always going to be 0. That was one of our properties. But in case you forgot your properties, remember that you can use change of base to put it in the calculator. And this is how this would go in the calculator. Just as a reminder, or in case you didn't get to the end of the lesson, it would be log 1 divided by log 2. This is how you would evaluate that in your calculator. Log of this number divided by log of the base. Okay? So just a reminder, that's how this goes in the calculator. And if you type that in the calculator, you're going to get 0. So we have to evaluate that. And now it's just a two-step equation. So everybody at this point, you're solving for r. We'll subtract 2 on both sides. We get negative 2 equals 3r, and then divide by 3. So r equals negative 2/3. Okay, so we want the base and the power and a number. We want it to look like that. Then we write it as a logarithm. Evaluate using the calculator, or if you can figure it out, that's great. And then just solve the equation. Okay. The next one we're going to do, this is the most involved type of exponential equation that we'll have. I just wanted to show it to you. I think you might have 2 of these in your homework, but these take the most work out of all the exponential kind. So we're going to set it up just like we set up the other one, but it's going to be a little bit weird because, well, you'll see just right now. So I'm going to do it the exact same way I did here. I've got log, my base is 81, of, this is my of, this is all of the stuff I'm going to have to write over here. 1/3 to the 2x, and that's going to equal what my power was. So I can check it out and double check and make sure it loops around. 81 to the x minus 1 equals 1/3 to the 2x. That's what it looked like. Okay. And so what you'd have to do at this point is remember with your power property, what can that 2x do that's up in the power? What can powers do? Where can they go? Do you remember? Remember your power property, if you have it in the exponent, it can just get shoved into the front. So the 2x can just get put into the front. So we're going to put that in the front. So that's one of our log properties. Powers can just go from the beginning to the exponent back and forth. And now we'll evaluate log base 81 of 1/3. Let's see what that actual number is. It looks like it's going to be, let's type it in the calculator, but I'm pretty sure it's negative 1/4. But let's double check. So I'm going to do log, hit the log button, 1/3, close it, divided by log of 81. And that is negative 1/4 or negative 0.25. You guys can't see my screen. Maybe you can. It's blinking, but it's there. So this is negative 1/4. So we've got 2x times negative 1/4 equals x minus 1. We'll just multiply it times 2. And now we're ready to go. So this is negative 1/2 or negative 0.5x equals x minus 1. Then we'll solve by subtracting the x first. So minus x on both sides. So negative 1.5x is equal to negative 1. Then we'll divide by 1.5. So x is negative 1 divided by negative 1.5, which equals 2/3. And all of that just can be done in your calculator. That's fine. So just to recap, when you have a base and a power and another base and a power, I just use the first one that I see. It's going to be my base. And I write it as a log. Take your power. It goes in the front. Evaluate your logarithm. And then just solve the equation. All right, let's try our next one. It's a lot less involved than the one that we just did. We have 15 raised to the n plus 10 is equal to 83. Is the base and the power, is it by itself yet? No. What do we need to get rid of? The 10. We're going to get rid of the 10. We're going to subtract it. So first we subtract 10 on both sides. So 15 to the n is equal to 73. And if you're trying to solve for something that is in the exponent for that variable there, we're going to write it as a logarithm. Okay. So this will be log, what's our base? 15 of 73, and that's equal to n. So we just do the log space 15 of 73 in the calculator, and we'll get our decimal answer. So just a reminder, this is what you type in.
Are you going to want the decimal answer?
Yeah.
Okay.
For the log ones, you'll want the decimal ones. With the ones that'll have E in it or L in, we just, most of the time we just leave L in for those, but the log we do. 73 divided by. Anybody got that? Anybody typed it in so far? It is a 1.58 once you put that into your calculator. Okay. Number 4 is very similar to number 3, except we have 9 times. How do you think we're going to get rid of this 9? What do we need to do first? We need to divide by 9, right, on both sides. So we'll divide by 9 first. It'll go away. And 76.7 divided by 9 is 8.52. We're repeating, 2, 2, 2, 2, 2. And at this point, I know we're going to write it as a log to get the exact answer, but we know it's going to be a decimal. But what whole number is our answer going to start with? 8 to what power gives you 8.5222? It's going to be to what power would that be? It's going to be a decimal, but what's the whole number that's going to be in the front? 1, right? Because it can't be 2, because 8 to the second power is 64. 8 to the first is 8. So we know it's 1 point something. So if you're doing this on the ACT, or if you're even doing it on this homework and you get to here, you're like, oh, well, it's going to have to be 1 point something. I'm not even going to mess with it in the calculator. If you can find that last step, if it's a multiple choice, just to save you some time. but we'll write it as a log to get our exact answer. Log base 8 of 8.522. Type it in again. And I got 1.03. So log 8.522 divided by log 8. Has everybody tried to do a log in the calculator so far? Like you did it on your homework or you've done it so far? Okay, if you haven't, make sure that you can get this same answer by typing it in. You can use the calculator on your Chromebook if you need to. But it's going to look like this when you do it. You don't have to do the fraction like the toolbar thing. Just do a divide. That's how I type mine in. It looks just like that. All right, so you think we're okay with the exponential kind? You get it by itself, we write it as a log and solve. Everybody all right with that process? No one's shaking their head up and down or left or are we okay? Thumbs up if that's all right. Okay. All right, so now we're going to move on to the log ones. The log ones we are going to, instead of writing as a log, I mean, it's already a log, we're going to write it as an exponent. So it looks like I started here with the natural logs. What is the base when you see the letters ln? What base is that going to be? It has an understood base of what? E, right. Yeah, it has understood base of E. So you might want to write that in your problem at the beginning. I know I'm going to have a base E right there. Okay. So it's the same thing as log base E. All right. So what we want to do, very similar to the exponential ones, we want to get the log part by itself, and then we're going to write it as an exponent. So we just do it in the reverse. Okay, so here's my log part. What is separate from that we need to move? The 4, right? So let's subtract 4 from both sides first. So we've got ln x minus 9 is going to equal 4. I'm going to keep writing my little e just so I remember. Okay. Now the logs by itself, we've got log of something equals a number, and it's perfectly ready for us to write in exponent form. So we're going to do our base to our power is equal to whatever we have in those parentheses or right next to it. So what is our base? Our base is our little number here. Our base is E. Remember to loop around. Raised to the 4 is equal to x minus 9. Okay. So e to the 4th equals x minus 9. With your problems with e in it, almost all the time they don't have you type that in the calculator. They just leave it. If they do say decimal form, you would just use the e button, which is on the same side as log and ln. Okay, but if you want x by itself, what are we going to do with this 9? Add it. So we're just going to say plus 9. So e to the 4th plus 9 is our answer. That is what x is. So get the log part by itself, write it as a power, and then solve for x. All right, go ahead and try number 6 and see how that goes. So very similar to what we just did. So see if you can follow those same steps that we just did on that. Oh, and Nia and Nick and An, I think you forgot to turn your cameras on. Thanks. All right, y'all getting close? You think you got it? Getting there? Y'all want to make sure we got the first couple steps. So the first thing, hopefully everybody got, you're going to add 9 to both sides. We all good there? All right, so we say plus 9 plus 9. We got the natural log of 2k equals -2. I always like to put it in parentheses just because, whatever. Okay, now at this point, I have log equals a number, and in my brain, I should say, well, I need to write that as an exponent so that I can get this k out of there. So what is our base? E. Is this sign language for E? E? Yeah. So it's E to the -2 is going to equal 2k. So we're going to write it like that. E to the -2 is equal to 2k. Okay. So it's k is almost by itself. What do we need to do to get it all the way alone? Divide by 2 on both sides. Okay. So k is going to equal e to the -2 over 2. If this was just me and it was a short answer question, I would take this as an answer. But a lot of times when you have multiple choice problems, they don't leave exponents as negatives. So remember that if you have a negative exponent on top, where is it going to go so it becomes positive? Yeah, you'll probably see the answer with the e to the second on the bottom instead. So I would take this if it was just a short answer, but just to let you know, in multiple choice land, they most likely leave a negative. They don't leave a negative exponent. They'll put it on the bottom. Or if it's on the bottom, they'll put it on the top. Okay. All right, so just remember ln has that base of e. Okay. Ooh, this one looks like fun. Here we go. This is a switch back to our log and or exponential and log one. So the problem like this, what are we going to move first? We're trying to get this by itself. We're going to move the 7 first. So -7. So -5 times 5 to the n minus 5 is going to equal -35. And then what do we do next? What are we going to move next? The -5, yeah. Some people get confused and they think they need to multiply these together. You don't ever multiply a number that's not raised to anything with a number that is raised to a power. So these two don't ever get combined together. So just make sure that you remember that. So now we've got 5 to the n minus 5 is equal to 7. We have a variable in our exponent. So what do we need to write this as? As a log. We're going to write it as a log. So go ahead and write it as a log on your paper. And then we'll see if everybody writes the same thing. So write that as a logarithm. All right. So hopefully we wrote this. Log base 5 of 7 is equal to n minus 5. Everybody good? Okay. All right. Then we'll evaluate log base 5 of 7 in our calculator. Log 7 divided by log 5. And get that number, which is something like 1.2, yada, 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 yada. And then once we get that, what are we going to do with our 5? We'll add the 5 to both sides. So I normally just like to do it in one step in my calculator. Evaluate that, and then hit plus 5 so that I don't have to rewrite that number with the decimal down. So I'll tell you what I did. I just did this in my calculator. I did that plus 5, and I got 6.21. So log 7 over log 5 plus 5. Yes, Michelle. I cannot hear you. I cannot hear you, Michelle. Let's see. Someone else try to talk and see. I was having sound problems yesterday too.
Hello.
Hello, Alan. Yes, got Alan. Okay. Michelle, try again. No? Nope. Okay. Interesting. Turn it up a little bit louder. Ah, that's too loud. Oh my goodness. All right, you can type it in, Michelle, if you want to. Yeah, log 7 over log 5. The number with the base, the base is always on the bottom. Like I always just think of like a base supports something, and that's going to be on the bottom part. All right. For the next type, these are a little bit different because you've got a log of something equals a log of something else. So if these two are going to be equivalent, don't the numbers that are in the parentheses have to match if you're doing the same operation on both of them? Like if I said x plus 2 and x plus 2, the x's had to match, right? So in this case, when you have log equals a log, and there's nothing else, no other number, we can just drop the logs completely off because these things inside the parentheses have to equal each other for it to be equivalent. So in this case, I can just get rid of that and solve the equation. So when you've got log equals log, you just drop the logs. Okay. I just solved that quickly and it was 8. But you always want to go back and check if you've got log of something that's in parentheses like that, and you would have to plug a number into it. When you plug the number into it, the thing in the parentheses can't be a negative. So you always want to go back and check it. Does 4 times 8 minus 4, that's a positive number, so that's fine. 3 times 8 plus 4, that's positive, so it's okay. Okay. Yeah, people always laugh when I say drop the logs, if somebody was laughing at that. Sorry about that. So you always want to plug it back in. If you get a negative when you plug your number in, it's not going to work out. The X value can be negative, that's fine. But just if you're putting it back in, because you can't take the log of a negative number that doesn't exist. All right, so let's look at number 9. Do we have log equals log in this one? Yep, so see you later. 27 plus 2n equals n squared minus 4n. I put this one in your problem, and there's some in your homework like this, just to remind you that if you have something squared in a problem, you want to move everything to one side and try to factor it. So once it's a quadratic, to solve those quadratic equations, move everything to one side. I'll pick the side with the positive n squared on it. I'm going to subtract 27 and subtract 2n. I'm going to line it up underneath these. So 0 n squared minus 6n minus 27. And what multiplies to 27 and adds or subtracts to 6? 9 and 3. So in this case, we have two answers. So our answers are positive 9 and negative 3.
I have a question.
Yes, blessings.
Okay, what did you say in the doing that minus 27, minus 29 that you have to do when dealing with squares?
Oh, when you have something squared, you just want everything on one side so we can factor it. You have to get 0 on one side, everything else on the other.
Okay.
I just subtracted them. I lined them up underneath where they would go just so it's easier to add and subtract. All right. So that was a log equals log. A little bit different. We didn't have to write anything as an exponent, just when those equal each other. All right, our next problem. We're going back to the exponential world again. What do we need to get rid of before we can write this as a logarithm?
Don't you have to set it into log form?
Yeah, first we got to get rid of this -2, then we'll do it as a log. So we got to get rid of this. So we'll divide by -2 first. Okay, so now it's an exponent. So to get rid of, or to get our variable out of the power, we're going to write this as a log. So here we go. Log, what's our base? E of, not negative, it's positive because I divided by a negative. There we go. Log base E of 41.5 is equal to 6a. And when you're evaluating this in your calculator, you can say log 41.5 divided by log E if you want. That will give you your answer. But log base E is the same thing as what? We have a different way to write that. The ln, right? So that is just ln of 41.5 equals 6a. Sometimes these problems will just leave the ln in the problem. Occasionally they'll be evaluated all the way out for decimals. So we just hit ln 41.5. Then once we get that answer, we're going to divide it by 6. So A is ln 41.5 divided by 6, which is 0.62. Y'all kind of getting the hang of sometimes you make it a log, sometimes you make it an exponent, just depending. We just switch back and forth. Kind of. Okay. Good thing you have a lot of homework problems to practice. All right, now more of the log kind. So if you saw number 11, the first thing you would think is I'm going to have to move what? The 9. You've got to move the 9, and it's 9 times log. So to move it, we need to divide both sides by 9. Okay, now you're looking at this. You're like, oh man, I got to get that b out of there. What do I need to do? How do I need to rewrite this so that the b is actually solvable? It's a log. So how do you rewrite logs?
Isn't it still a log 12?
Oh yeah, sorry. I wrote 2 instead of 12. It's log 12. So we are going to write, what's our base going to be? 12. That's our base, it's our little number here. To the 4 equals b minus 7. Okay, so we just type in 12 to the 4th in our calculator. That's 20,736. And if you want b by itself, what are we going to do with the 7? Add it to both sides. All right, let's try number 12. Y'all can help me out. What is the first thing that we do on number 12? What do we get rid of? We subtract the 8 on both sides, right? So log of x plus 5 equals 4. This is another one of our common logs. The first one we talked about earlier was when we had ln that had a base of e. If it's log and there's not a base underneath, what is our understood base there? That is 10, right? If you remember from the video, if there's not a number written there and it says the word log, this is an understood base 10. Okay. So now go ahead and write that as a power and solve that equation. See if you can do it. So remember, you have log equals a number. We're going to write it as a power.
So, are we going to log it, or are we just going to do the base?
We're going to do the base. It already is a log. So if you see log, you're going to write it as an exponent. So our base is 10
And to the 4th?
to the 4th equals x plus 5. And 10 to the 4th is a 1 with 4 zeros. when we subtract our 5. Okay. All right, we are very close to being done with these just regular equation ones. And we have a couple of the word problems where we're not just solving for the total value, we're sometimes solving for interest or sometimes solving for the year. So we'll see. But just kind of as a reminder, log equals log, drop the logs. A base to a power equals a number, write as an x, write as a log. If it's a log equals a number, we write as an exponent. Okay. Did I click the wrong one? Did y'all have 2 more questions? Or were those your only 2? You did have 2 more? I thought I had 2 more questions on here. I guess this was a different file. Let me pull up those other 2 real quick because I need to show you guys those before we do the word problem ones. Sorry. It's these 2. Nope, not those 2. Where are they? These 2. Okay. All right, back to my page. Sorry about that. I didn't hit save when I changed this yesterday. So I guess this is going to be like 12.1 and 12.2 because y'all already have 13 and 14 on your page. So here's just a couple more that we have to evaluate, or we have to condense before we can solve. So it's a good reminder of, I wrote the wrong one, sorry. So we have log base 7 of 6 minus log base 7 of 3x is equal to 2. That's our first one. That'll be our second one. Okay, sometimes before we can rewrite something as an exponent or solve a log equation, we have to condense logarithms together because you can't solve it if you've got 2 logs on one side. So you have to remember what a minus between a log means and what a plus between 2 logs means. So if I've got a log minus a log, if you remember from your condensing, minus translates into divide, right? When you're going to put them together, if you have a minus between 2 logarithms, that's going to be a division. So I'm going to condense these together to be log base 7 of 6 divided by 3x. So that was from the end of the lesson the other day. You've got a minus translates to a divide when you do a single logarithm. Okay. Now at this point, this is very similar to what we just had on there. Let's go ahead and write it as, what do we need to write it as? It is a log. We're going to switch it into an exponent. So what's our base? 7 to the second equals 6 over 3x. So 49 is 6 over 3x. We can simplify 6 over 3 if we want to, or we can just not worry about it right now. But we need to get this x out of the denominator. So let's multiply by 3x on both sides. So 49 times 3, 147. So I just multiplied by 3x on both sides to get that over there. So 147x equals 6, and then we divide both sides by 147. Which simplifies to 2 over 49, or you can say the decimal, that's also fine. Okay. So when it's a minus, it translates to divide. Now we'll look at our plus. When you have two logs added together, plus turns into a what? What are you going to do? It's going to be times. So I'm going to have log base 8, and I'm going to do 10 times x minus 8. So that's going to be 10x minus 80. I forgot my 8 right there. Everybody okay to get 10x minus 80 added 10 times x minus 8? Just went ahead and distributed it. Are we going to write this problem as an exponent? No, what do we need to do in this problem? Look at how it's set up. We're going to drop our logs. We got log equals log, so the logs get dropped. So we just have 10x minus 80 equals 32. Y'all can solve from here. Okay. We're just going to do the first two of the word problems. I think that's probably all that you guys need to see. So here we go. Y'all have some like the rest of them, but we're not going to work them all out in the examples. Once you know how to set them up, we're just solving the problems like we did before. Yeah. So our first problem, we have Narachi. She invests this much in this with a fixed annual interest rate compounded 6 times a year. How long will it take for the account balance to reach this number? So we're going to fill everything in that we need to know, that we know in our formula. And it says 6 times a year. So we have to use our formula with the n in it. So remember that we had A of t equals P1 plus R over n to the n t. So that's the formula we're going to use, and we're going to have to solve for n. So our final amount is the 26,000. 1,179.86. Our initial is to 6780. We've got 1 plus 0.08 over 6 raised to the 6 times t. So we're trying to get something out of a variable, which means eventually we'll need to write it as a logarithm. But what I like to do on these problems, do I have everything that I need inside of the parentheses? Like, could I evaluate that in the calculator and get an actual number instead of having this plus? So I do that at the very beginning. I would say 1 plus 0.08 divided by 6 and get a decimal for that, okay? That helps me to see clearly that this problem is very similar to the ones we just did. They just have decimals. So I want to get it to where it's a base to a power equals a number. So what do I need to get rid of first? So that it's just a base to a power. What's in the way of it being that? The 6780, right? Yeah, we're going to divide everything by 6780. And that gives us 3.861 equals 1.013 to the 6t. And now it's in perfect form to write it as a logarithm. What is our base going to be? The 1.013. So log 1.013 of 3.861. If you want to put the 3.861 on the other side, if that helps you when you're writing as a logarithm, that's fine. And that's going to equal 6 times t. So then we just put it in the calculator. Log 3.861 divided by log 1.013. And then I get 104 point something, but I know I'm going to have to do what at the very end to get t by itself? Divide by 6. So I'm just going to go ahead and hit divide by 6 in the calculator, because I ran out of space. So it will take 17.43 years for it to reach that balance. So we put our numbers in, see if we can go ahead and combine those. If we can, and our variable's in the power, it's perfect for us to do as a logarithm, okay? We're going to set up 14, and I'm going to show you why you wouldn't use a logarithm in this problem. And some of them you don't. You only have to do it if you're trying to get the variable, if the variable is in the exponent. So this one, we've invested this much, it compounds 3 times a year. If the balance reaches that, what is the interest rate? So we're trying to find something inside of our parentheses. So I'll show you how to set that up. So it's the same equation. We got 2868.80, 1539. 1 plus, I don't know my rate, and that's raised to the 3 times 9. So if we are trying to get this r by itself, we don't have a variable in the exponent, so logs aren't going to come into play. This is all just stuff with powers that you've done before. But what would be the first thing you would want to get rid of on this side before you can get to this? The 1539. Yep, we're going to divide by that. So that's our first thing that we do. So that gives us 1.864. Which is equal to 1 plus r over 3 raised to the 27th. I just did 9 times 3. Okay, we have to get rid of this power in order to get to the variable. And this is just a reminder. I just want to show you this part. I'm not going to work the rest of the problem. I'm just going to do this one step. Y'all can get the rest of it. So to get rid of something raised to the 27th, you're going to raise both sides to the 1 over 27th. So you do the reciprocal of that. Just a reminder of how to get rid of a power. That's 1.023. And then to get r by itself at this point, we subtract the 1 and then multiply by 3. So ... y'all can finish that one. Oh, you were talking, I just saw this, Mackenzie, sorry. That was a 6. Okay. I just wrote that down wrong. And you've also got some on your assignment where you're doing it with compounded continuously. So that's your PE to the RT kind. So you still are solving for the variables. And sometimes they ask you, what is the initial amount? If they give you the final amount and everything else, that's pretty easy to do. You've got this, you've got all of that. Just evaluate that as a number and you'll divide it. So there's nothing with logs or anything involved. The only kind with logs is if they're asking you to find the time. I'm not ever going to ask you to find the n because it shows up in 2 places. So if they ask for times, that's when we got to write as logs. Otherwise, we just solve using equation solving techniques you've seen before. So if it's log equals log, what do? You drop the logs, right? If it's log equals a number, we write it as an exponent. If it's base power equals a number, we write it as a log, right? So base power is a number, write it as a log. So exponents you write as logs, logs you write as exponents, log equals logs, see you later and solve. Okay? So just if you're, hopefully you're getting used to cycling back and going back and forth between logs and exponents. It's a lot of good practice on these equations of doing that.